Hello everyone, today we are going to be going over the 8.5 and 8.6 warm-ups. 8.5 covers the relationships between angles, and SOL 8.6 covers the volume and surface area of three-dimensional figures. As I've stated on Google Classroom, we were unable to cover three-dimensional figures before school closing, so I will give a more thorough review of that information in this video. Starting with our SOL 8.5 warm-up, question number 1 says name as many types of angles as you can and sketch pictures of what they look like. First, let's start with our types of angles. There are 4 major types of angles. The first is acute. An acute angle is any angle with a measurement less than 90 degrees. Next, we have a right angle. Right angles have measurements of exactly 90 degrees, and they're often notated with this small corner notation. An obtuse angle is any angle that has a measurement that is greater than 90 degrees. Finally, we have our straight angle, and a straight angle has a measurement of exactly 180 degrees. There can also be relationships between 2 or more different angles. The first is complementary. Complementary means that 2 or more angles have a sum of 90 degrees. An example is here with angles A and B. Those 2 angles are complementary because together they make up a right angle. We also have supplementary angles. Supplementary angles are 2 or more angles that have a sum of 180 degrees. Here is an example of 2 supplementary angles, C and D, because together they make a straight angle, which is equal to 180 degrees. We have 2 more examples of the relationships between angles. The first is vertical. Vertical angles are formed by the intersection of 2 straight lines, and vertical angles are across from one another, such as angle 1 and angle 2. Vertical angles are also congruent, so angle 1 has the same measure as angle 2. Finally, we have adjacent angles. Adjacent angles share a side and a vertex. So here, these 2 angles, 3 and 4, they are adjacent because they share this side and this vertex. Moving on to question number 2. Match the following terms with the appropriate image. So first, we're looking for the set of complementary angles. One way to remember complementary is it starts with a C, as does the word corner, and a corner is 90 degrees. Looking through our 3 examples, here we have 2 straight lines intersecting, forming 2 congruent angles, so that is not complementary. Here we have what appears to be a 90-degree angle and 2 angles making it up, so that is complementary. Supplementary starts with an S, as does the word straight. A straight angle is 180 degrees, and so are supplementary angles. Looking at this bottom, we have a straight angle made up by 2 angles, so this is our supplementary angle. Vertical angles are formed by 2 straight lines and are across from one another, which we found in the first example. Number 3, what type of angles are shown below? Solve for the variable. If we look, we have a straight line making up 180 degrees, and we have 2 angles making it up. So these are supplementary. Because they are supplementary, we know that 68 degrees plus the measurement of angle N is equal to 180 degrees. If we want to isolate the variable, we need to subtract 68 from each side, and N is equal to 112 degrees. Before we move forward with this portion, I want to give a small mini lesson on surface area and volume of three-dimensional shapes. This is the Virginia Department of Education's Grade 8 Mathematics formula sheet. Starting in the middle of the second row, we start with our three-dimensional figures. Here, we have a rectangular prism. It has a length, a width, and a height. It has all of its faces are made up of rectangles. And it has two formulas. So volume is equal to length times width times height. And surface area is equal to 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. With solving for volume and surface area, it's a lot like variable substitution, except for instead of the expression being given to us, we need to use our formula sheet to find the correct expression. We also need to use either the word problem or the diagram to find what each of the variables is represented by. So here's an example of a rectangular prism, and we want to find the volume. Well, looking at our formula sheet, the volume is equal to length times width times height. So I write that down. Now I need to identify what each of the variables is equal to. So what is L equal to? What is W equal to? And what is H equal to? We have our length of 10. We have our width of 3. And we have our height of 2. For rectangular prisms, it does not matter which you list as the length, the width, and the height, as long as you use each number once. Now we are going to take this information and we're going to put it into Desmos. When we put this into Desmos, it is important that you do not put the V equals. So we're just going to start with our expression, which is length times width times height. Then we need to, because we have this orange triangle, that is an error because Desmos does not know what those variables are equal to. So we need to tell it. L is equal to 10. Enter. Make sure you enter after every variable. W is equal to 3. Enter. And H is equal to 2. Enter. So if we go back to the top where we have our original expression, the volume is equal to 60. Now volume is always in cubic units, so we could write this two ways. We could say cubic inches, or we could say inches cubed. You may see it either way. Let's move on to surface area. Our formula for surface area, according to our formula sheet, is 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. And just as before, we need to know what L is equal to, what W is equal to, and what H is equal to. Fortunately, all of this information is exactly the same as the volume. The length is 10, the width is 3, and the height is 2. Now, just like the volume, if for some reason you use these numbers in the wrong order, you'll be just fine as long as you use every number once. So now we open Desmos and we follow the exact same protocol. First, we type in our formula, 2 times L times W plus 2 times L times H plus 2 times W times H. Hit enter. Then we say L is equal to 10. Enter. W is equal to 3. Hit enter. And H is equal to 2. We go to the top and we see that we get the answer of 112. Just like area in a two-dimensional figure, surface area is in square units. So here we would say square inches, or we could say inches squared. Going back to our formula sheet, we're going to talk about cylinders next at the end of the second row. Cylinders have two circular bases. The volume is pi r squared h, where r is the radius and of one of the bases and h is the height of the entire cylinder. And surface area is equal to 2 pi r squared plus 2 pi r h. Remember that pi is not a variable, it is a number. It is the ratio of the circumference to the diameter of a circle. So here's an example of a cylinder here, and we want to find its volume and surface area. So first we need our formula. Volume is equal to pi r squared h. So we need to define what r is equal to and what h is equal to. Looking at our diagram, this goes all the way across. So that is a diameter. The diameter is 3. The radius of a circle is half of the diameter. Since half of 3 is 1.5, our radius is 1.5 yards. Our height here is 5 yards. So we follow the same protocol and we put this information into Desmos and it will tell us the volume. Now because we are using pi, we are going to get an irrational answer. So for this exercise, we are going to round to the hundredths place. So we start by typing in our expression, remembering not to put in the v equals, and we say pi times r squared h, hit enter. R is equal to 1.5 and h is equal to 5. So we get a volume of 35.34. Just like with rectangular prisms, this will be in cubic yards or yards cubed. Now let's move on to surface area. The surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. We are going to use the same radius and height as before. So the radius is equal to 1.5 and the height is equal to 5. First, we need to put our expression into Desmos. So 2 pi r squared plus 2 pi r h, hit enter. R is equal to 1.5 and h is equal to 5. So we end up with a surface area of 61.26. And just like a rectangular prism, this will either be in square yards or yards squared. Now let's talk about pyramids. Pyramids are on the last row in the first column. A pyramid has a square base with 4 triangular sides that come to a point. The volume is 1/3 capital B H. If we look down on our formula sheet, we can actually see that big B is equal to the area of the base. So we may need to refer to some of these two-dimensional formulas at the top, primarily the square. H stands for the height of the pyramid, which goes from the very top point down to the base, hitting it perpendicularly. The surface area is equal to 1/2 LP plus capital B. There are a few things to dissect here. Lowercase l stands for slant height, and that is different than the height. The slant height is the height from the point of the triangle down to one of the edges, sloping down the side of one of the triangular sides. P as indicated in the chart at the bottom, stands for the perimeter of the base. So in order to find P, you will need to find the perimeter of the square at the bottom. And of course, you will also need to find the area of the base. So let's look at our example here. We need to find volume and surface area. So volume is equal to 1/3 times the area of the base times the height. So we need to define what capital B is equal to and what H is equal to. Area of the base refers to this entire area down here. Now this is a square where all sides are 12 inches. So in order to find the area of a square, we do length times width, or 12 times 12, which is 144. Do not get the height and the slant height confused. The height is the red line. It goes from the very top point straight through the middle of the space of the prism, or of the pyramid. So the height is 8. Just as before, we're going to use Desmos to do the rest of the work for us. We're going to type in 1/3 capital B, lowercase h, hit enter. It's important to note that if you use a capital B in the expression, you must use a capital B below. So big B is equal to 144. And H is equal to 8. So we end up with 384. Just as before, this is going to be in cubic units. So this is either cubic inches or inches cubed. Now let's move into the surface area. The surface area of a pyramid can be found with the formula 1/2 LP plus capital B. So we need to find L, P, and capital B. Well, if we look, the slant height is 10. It is the height from the top of the pyramid to the base, sloping down one of the sides. So we already know that the slant height is 10. Now we need to find the perimeter of the base. Remember that our side, it's a square, so all the sides are the same. So we need to do 12 plus 12 plus 12 plus 12. And we get 48. We already found the area of the base, which is 144. Just as before, we can use Desmos to make this process a lot simpler. First, we type in our formula, 1/2 times LP plus capital B, and hit enter. L is equal to 10. P is equal to 48. And capital B is equal to 144. So surprisingly, we end up with a surface area of 384. Just like with our rectangular prism, it is square units. So this is going to be square inches or inches squared. Now this is a particularly special case where the volume is equal to the surface area, but please know that this will not always be true. We are going to end this session with a cone. If we look at our formula sheet, a cone can be found, or a cone has a height and a slant height, very similar to a pyramid, but it has a circular base, so it also has a radius. The volume can be found with the formula 1/3 pi r squared h, or the surface area can be found with the formula pi r squared plus pi r L. So let's start with our volume. Volume is equal to 1/3 pi r squared h. In this example, our radius is here. It goes from the center of the circle to the edge. So r is equal to 7. Remember that the height goes through the middle of the cone. So our height is 12. We're going to put this information into Desmos and we're going to round to the nearest hundredths place. So 1/3 pi r squared h, and r is equal to 7, and h is equal to 12. So we end up with a volume of 615.75. Again, it's going to be cubic kilometers or kilometers cubed. Now let's try our surface area. We can find the surface area of a cone with the formula pi r squared plus pi r L. So we need to define r and L. R again is that 7, and the slant height is going to be this blue number because it's that slanted height down the side of the cone. So R equals 7 and L equals 13. So we're going to put in our formula pi r squared plus pi r L. R is equal to 7 and L is equal to 13. So we end up with a surface area of 439.82, and it's going to be square kilometers or kilometers squared. So with that mini lesson, let's get back to our warm-up. Determine whether each scenario involves perimeter, area, surface area, or volume. Perimeter and area have to do with two-dimensional shapes, while surface area and volume have to do with three-dimensional shapes. Perimeter and surface area usually mean going around the outside. So for a two-dimensional figure, that might be like a fence around a yard. For surface area, we're covering the entire object. So that might be wrapping it up in paper. Area and volume are where we fill the shape in. So for area, that could mean the tablecloth covering a table. Or for volume, it could mean the amount of water in a pool. So if we are wrapping a birthday present in a square box, it is a box, so it's a three-dimensional shape. And since we're covering the outside, we're not filling it with paper. That is surface area. If we're putting in a new fence around a garden is a pretty flat thing, so that's two-dimensional. And since we're putting that fence around the outside, that's perimeter. Filling a jug with lemonade. A jug is a three-dimensional figure. And since we're filling it with something, that's volume. Painting a canvas. A canvas is a flat two-dimensional shape. And if we paint it, we're covering it. We're filling the canvas in. So that's area. Putting a label on a soup can. A soup can is a three-dimensional figure. It's a cylinder. But if we're only covering the outside, that's surface area. The problem says to find the volume and surface area of a rectangular prism with a length of 11 inches, a width of 6 inches, and a height of 8.5 inches. So we know that we're finding volume and surface area. So we're going to need formulas. And it's a rectangular prism, so we need to look under the rectangular prism on our formula sheet. Well, the volume of a rectangular prism is LWH, and the surface area is 2LW plus 2LH plus 2WH. We define our variables through the rest of the information. L is equal to 11, W is equal to 6, and H is equal to 8.5. And that information is the same for both the volume and the surface area, so I'm not going to write it twice. So let's try Desmos. Let's type in our formula, LWH. L is equal to 11. W is equal to 6. And H is equal to 8.5. So we end up with a volume of 561 inches cubed. We're going to find surface area, but we only need to change the expression at the top. So 2LW, plus 2LH plus 2WH. And of course, we already have what L equals, W equals, and H equals. So we end up with a surface area of 421 inches squared. We're going to find the volume and surface area of this square-based pyramid. First, we need our volume and our surface area formulas. So the volume of this pyramid is 1/3 capital B lowercase h, and the surface area is equal to 1/2 LP plus B. So let's define some variables first. Let's talk about capital B, let's talk about H, let's talk about L, and let's talk about P. P is the area of this base, so we need to do the length times the width. 10 times 10 equals 100. We're going to skip the height for now because the height is right here, but we don't have a number. And I'm going to teach you today how to find it. The slant height is 13. And to find the perimeter, we need to go 10 plus 10 plus 10 plus 10, which is equal to 40. Now the height is missing, but if you look very carefully, the height, the slant height, and half of a side form a right triangle. Now, this part of the right triangle does not go the entire way across, it only goes halfway, so it has a distance of 5. Now, we learned how to use the Pythagorean theorem to find the missing side of a right triangle, so we're going to do that here. We know that a squared plus b squared equals c squared. Our hypotenuse is c. Our legs are a and b. So we have h squared plus 5 squared equals 13 squared. So h plus 25 equals 169. And h is equal to 144. Or h squared, excuse me. So h is equal to 12. Now we're going to use Desmos to finish up the problem. So our formula for volume is 1/3 capital B lowercase h. And I'm actually going to do both at once. I'm going to go ahead and put the surface area formula as well, which you can do. 1/2 times LP plus capital B. And now I'm just going to put all 4 variables. So capital B is equal to 100. H is equal to 12. L is equal to 13. And P is equal to 40. So if we look at the top, our volume is going to be 400 cubic meters or meters cubed. And our surface area is equal to 360 square meters or meters squared. I hope this video was helpful for you today. If you have any questions, feel free to email me or ask them in the comments below.